Hello everyone, myself Mohit Tiwari, MCA department from Tecnia Institute of Advanced Studies, going to present a lecture on OSI Reference Model. The OSI means Open System Interconnections. The OSI model is based on a proposal developed by International Standard Organization as a first step towards international standardization of the protocols used in various layers in 1983, and it was revised in 1995. The model is called the ISO OSI Reference Model because it deals with connecting open systems that are open for communications with other systems. We will just call it the OSI model for a short forms. The OSI model has 7 layers. The principle that were applied to arrive at the 7 layers can be briefly summarized as following. Number 1, a layer should be created where a different forms is needed. Second point, each layer should perform as well-defined functions. Third point, the function of each layer should be chosen with an eye towards defining internationally standardized protocols. Fourth number is, the layer boundaries should be chosen to minimize the information flow across the interface. Last point is, the number of layers should be large enough that distinct functions need not be thrown together in the same layers out of necessity, and small enough that the architecture does not become unwieldy. Below, we will discuss each layers of the models in turns starting at the bottom to top. Note that points, the OSI model itself is not a network architecture because it does not specify the exact service of the protocols to be used in each layers. It just tells what each layer should do. However, ISO has also produced standards for all the layers, although these are not part of the reference model itself. Each one has been published as a separate international standards. The first layer of OSI reference model is physical layers. The physical layer is connected with transmitting raw bits over a communication channels. The design issue have to with making sure that when one side sends a 1 bit, it is received by the other side as a 1 bit, not as a 0 bit. Typically, questions here are how many volts should we use to represent a 1 and how many for a 0 bits. In both directions, how the initial connections is summarized and how it is torn down when both sides are finished, and how many pins the network connector has and what each pin is used for. The design issue here largely deal with mechanical, electrical and timing interface, and also the physical transmission medium which lies below the physical layers. The data link layer. The main task of data link layer is to transform a raw transmitting facility into a line that appears free of undetected transmission errors to the network layers. It is the pack of task by having the sender breakup and input data into data frames and transmission the frames sequentially. If the service is reliable, the receiver confirms correct receipt of each frames by sending back a acknowledgement frames. Another issue that arises in the data link layer is how to keep a fast transmitter from drowning a slow receiver in the data. Some traffic regulation mechanism is often needed to let the transmitter know how much buffer space is received has at the moment. Frequently, this flow regulation and the error handling is integrated. Broadcast network has an additional issue in the data link layer also, how to control access to the shared channels A special sublayer of data link layer that is called medium access control sublayer deals with these problems. Next layer is network layer. The network layer control the operation of the subnets. A key design issue is determine how packets are routed from source to destinations. The routes can be based on static tables that are wired into the network and rarely changed. They can also be determined at the start of each conversion. For example, a terminal session may be determined from source to destinations. Finally, there can be highly dynamics being determined for each packets to reflect the current network load. If too many packets are present in the subnet at the same time, they will get in one another's way, forming bottleneck may be better example for that particular things. The control of such congestion also belong to network layer. More generally, the quality of service provided is also a network layer issue. When a packet has to travel from one network to another to get to its destinations to source and vice versa, source to destinations, because here all layers are work in a full duplex forms. Many problems can be arise for that particular situations. The addressing used by the second network may be different from first and another's. The second one may not accept the packets at all because it is too large. The protocol may differ and so on. It is up to the network layer to overcome all these problems to allow heterogeneous networks to be interconnected. In broadcast network, the routing problems is simple, so the network layer is often thin or even non-existent. Next layer is transport layer. The basic function of transport layer is to accept data from above, split it into smaller units if needed, and pass these to network layers, and ensure that the pieces all arrive correctly at the other ends. Furthermore, all this must be done efficiently and in a way that isolated the upper layers from the eventual changes in the hardware technologies. The transport layer also determines what type of service to be provided to session layers and to users of the networks. The most popular type of the transport connections is an error-free point-to-point channel that deliver message or bytes in the order in which they were sent. However, other possible kind of transport services are the transporting of isolated messages with no guarantee about the order of delivery. That means the response of the delivery messages and the broadcasting of message to multiple destinations. The type of service is determined when the connection is established. The transport layer is a true end-to-end layer all the way from source to destinations. In other words, a program on the source machines carries on the conversion with a similar program on the destination machines. Using the message headers and control messages, in the lower layers the protocols are between each machine and its immediately neighborhood and not between the ultimate source and destinations machines, which may be separated by different routes. Next layer is session layers. The session layer allows users on different machines to establish session between them. Session offer various services including dialogues, controls, token managements, and synchronizations. And last layer is presentation layer. Unlike lower layers, which are mostly concerned with moving bits around, the presentation layer is concerned with the syntax and semantics of the information transmitted. In order to make it possible for computers with different data representation to communicate, The data structures to be exchanged can be defined in an abstract way along with a standard encoding to be used with the wires. The presentation layer manages these data structure and allow higher level data structure to be defined and exchanged. Next layer is application layers. The application layer contains a variety of protocols that are commonly needed by users. One widely used application protocol is HTTP, that means Hypertext Transfer Protocols, which is basic of the www, that means World Wide Webs. When a browser wants to a page, it sends the names of the page it wants to serving using HTTP. The server then sends a page back. Other application protocols are used to file transfer, electronic mail, and network news. This is all about the OSI reference model. Now we start the TCP/IP reference model, that means transmission control protocols. Let us now turn from OSI reference model to the reference model used in the grandparent of all the wide area computers networks and its successors, that means over the internet. Furthermore, a flexible architecture was needed since applications with the divergent requirement were envisaged, ranging from transferring file to real-time speech transmissions. In TCP/IP reference model, there are various types of layers. First one is internet layers. The internet layers define an official packet format and protocols called IP, that means internet protocols. The job of the internet layers is to deliver IP packets where they are supposed to go over there. Packet routing is clearly the major issue here, as avoiding conjunctions on the one network to another network after or before transmissions. For these reasons, it is reasonable to say that the TCP internet layer is similar in functionally to OSI network layers. Next layer of TCP/IP protocols is transport layer. The layer above the internet layer in the TCP model is now usually called the transport layer. It is designed to allow peer entity on the source and destinations host to carry on a conversion, just as in the OSI transport layer. Two end-to-end transport protocols have been defined here. The first one, TCP, is reliable connection-oriented protocols that allow a byte stream organizing on a one machine to deliver without error on the another machines in the internet. It fragments the incoming bytes stream into discrete messages and pass each one onto the internet layer. At the destination, the receiving TCP process reassemble the received message into the output streams. TCP also handle flow control to make sure the fast sender cannot swap a slow receiver with more messages than it can be handled. The second protocols in this layer is UDP, that means user datagram protocols. UDP is an unreliable connectionless protocols for applications that do not want TCP sequencing or flow control and wish to provide their own. It is also widely used for one-shot, that means client-server types, request-reply queries, and application in which prompt delivery is more important than accurate delivery, such as transmitting speech or videos. The third one layer is application layers. The TCP/IP model does not have session or presentation layers. No need for them was perceived, so they were not included. Experience with the OSI model have proven this view correct. They are of little use to most applications. On top of the transporter layer is application layers. It contains all the higher level protocols. Next layer is host-to-host network layer. Below the internet layer is a great void. The TCP reference model does not really say much about what happens here, except to point out that the host has to connect to network issue. Some protocols show it can withstand IP packets to it. These protocols not defined and varies from host to networks. Now a comparison sheet of OSI and TCP reference model. The OSI and TCP reference model have much in common. Both are based on concept of a stack of independent protocols. Also, the functionality of the layers is really similar. For example, in both models, the layers up through and including the transport layer are there to provide an end-to-end points. These layers form to transport providing. Again, in both models, the layers above transport are application-oriented user of the transport services. This is all about the OSI reference model and TCP reference model. I hope all you are understanding better about the OSI reference model and the basic functioning and the delivering of the one point to another points of the OSI reference model for the data transmission in the network forms. Thank you very much for giving your valuable time.